Okay, let's start. Let's start. Today I'm going to start statistic lesson. Statistic lesson. Then within 2 days, maximum 3 days, we can complete fully theory part with advanced level questions. Okay, now first analyze what is statistic. This is very simple question. There will be part A question, question number 10, and part B question number 17, part B. Question number 17 part B will be statistic, and question number 10 will be statistic question. And question number 17 part A probability, question number 9 will be probability question. Very simple mark, altogether 20 mark. 20 mark for statistic and probability. Very special part, that is not related with any other thing. Okay, then this is statistic probability isolated part. Then you can totally earn this statistic probability full marks, 20%. Okay, now consider what is statistic first. So it is about data. Okay, statistics mean it is about data. We have to analyze data set. We have to analyze data set. So there can be different types of data. One is quantitative data and the other one is qualitative data. One is quantitative and qualitative. Okay, you consider weight, then it has 53 kilograms. It has quantity. Okay, then it has numerical value. Then those are we call quantitative. So there can be another data set we call qualitative data. Girls, boys, girls, boys. Then boys count quantitative, but boy mean qualitative. Then likewise there are two different types of data, quantitative, qualitative. Therefore, the statistic mean we have to collect data and we have to gather that. Thereafter we have to arrange data. Thereafter we have to analyze it. Collection, data collection, arrangement, then analysis we call statistic. Okay, data collection, then arrangement and analysis we call statistic. Then first data collection, we have to do some practical. We have to do some practical to collect that data. Therefore, you consider here I'm going to evaluate maths of Sri Lankan students. Maths of Sri Lankan students. Therefore, I need to consider whole Sri Lanka. I have to consider all. Then I need to give common paper for all. I have to evaluate all. Then I can analyze it. Then only I can analyze it. Then this full set we call population. Population. Full set we call population. But with my capacity, I can't select all, no? If I am alone, I can't do that one alone. Then thereafter, I have to select few of them. I'm going to select 100 of them. Then that one we call sample. Sample. So then full set Sri Lanka we call population, but according to my capacity, I can't do that. Therefore, I have to select only few students. Then that few student we call sample. Then you select that sample, give that paper and evaluate it. Then we can consider the sample. Thereafter we can say the things about population. Therefore, there are sampling techniques. There are sampling techniques. That is data collection. Data collection. So in our A-levels, we don't have anything like that. That is practical thing. So data collection not in our A-levels. Data collection we don't have. Then thereafter, after gathering data, you see, so after doing that paper, I'm going to collect that. I'm going to write on this paper. So 10 mark, 12 mark, 15 mark, 14 mark, 100 mark, 25 mark, then 37 mark, so on, I'm going to write. Here this is just collected data, no? Just collected data. That just collected data we call raw data. Raw data. So that is not arranged, no? That is not arranged. So we can't analyze this type of data set. Then before analyzing, we have to arrange it. Before analyzing, we have to arrange it. then there are different type arrangement technique. One is ascending order arrangement. Ascending order arrangement. By ascending order arrangement, we can see what is the minimum value and what is the maximum value, what the range. Ascending order arrangement. And if we have ascending order arrangement, if we consider mid value, that is we call median. Then mid value we call medium. Then lower, higher and range, and the mid value we can obtain. And also you consider here, if you arrange that data set, here lower element, here higher element, here mid value we call median. Then if you again split into two, one midpoint here and another midpoint here, this is we call quartile. First quartile, here third quartile, median also we say second quartile. Likewise, we can split into 4 segments. Then those segments, here this point we call first quartile or lower quartile, here mid quartile or median or second quartile, here upper quartile or third quartile. Likewise, we can analyze them. So when we arrange ascending order, then only we can do that. So without arrangement raw data, we can't do. Now you consider, in my class there are 15 students. Then no worries, I can write 10 marks, 15 marks, 12 marks. Likewise, I can write that along a line. No? I can write that along a line. Then no need to worry about, because the count is very low, number of students very low. Therefore, I can write that marks along the line. Then here this data arrangement we can say ungrouped data distribution. Ungrouped data distribution. Now you think, now there are around 100 students. So if I write marks along a line, it is somewhat long, no? Too long. Therefore, because of this, I can arrange them like this. First count 10 marks, then 3 students, 15 marks, 2 students, 20 marks, 5 students. Likewise, then 25 marks, 10 students. Likewise, we can further arrange, no? So here I just write all data along a line. Here 10 students, count 3, 15 mark, count 2, 20 mark, count 5. Then here this is we call frequencies. These are we call frequencies. Then number of students mean frequencies. Then this is another arrangement type. Here this data set somewhat larger than this one. No? Here just around 15 students, this is just around 100 students. Then here this is we call, this type of data distribution we call ungrouped frequency distribution. Ungrouped frequency distribution. Then you see, now you think here, now there are around 1000 students. Now we can't write this way, all marks we can write this way, and this one also somewhat large. Therefore, we have to group them. Now you consider 0 to 10 mark 5, 10 to 20 mark 10, 20 to 30 mark 50, 30 to 40 mark, then here 100. So on we can group them. No? So here 0 to 10, 5 students, 10 to 20, 10 students, 20 to 30, 50 students, so on. So here this is we call grouped. Here frequency, it is distribution. Then this is we call group frequency distribution. Grouped frequency distribution. Group frequency distribution. Therefore, in our A levels, we have to analyze about ungrouped data distributions. So most probably that will be in your part A question. Then there can be ungrouped frequency distribution. And here group frequency distribution, most probably Part B question comes with group frequency distribution. Group frequency distribution. Anyway, we have data. Those data set numerical values. Therefore, we have to analyze numerical data set. Then using that data set, we can analyze it by calculating some parameters. That is statistic. Okay. Therefore, with my capacity, I can select population or I can select a sample. Okay. With my capacity, I can select full population or sample. So there are different types sampling techniques. So according to that, we can select one sample and we can give a paper or whatever. Then we can get data, collect data, and thereafter we can analyze that data set. Then when you consider this one, group free data distribution, ungrouped data distribution, complete data mentioned in there, no? Without any loss. Here also, we don't have any loss here. 10 mark 3 students, 15 mark 2 students. But here there's data loss, no? 0 to 10, 5 students. We don't know what the mark here. But we know only 0 to 10. Within 0 to 10, 5 students. 10 to 20, 10 students. Then here, there's data loss here. Here we have data loss. But we don't worry about that. We have to analyze the thing. Statistic mean we have to analyze the data set, but we don't worry about the final results. We try to get optimal results. A good result using theorems on statistic. That is statistic, okay? So I have given a tutorial. First take that one. Okay, now take it. First start reading. I'm not giving any notes because that's not that much compulsory. So statistic is a branch of science dealing with collecting, organizing, summarizing, analyzing, making decisions from data. So we have to play with data, that's it. Then there are two types of statistics. One is descriptive statistic. So descriptive statistics deals with method of collecting, organizing and describing data using table, graphs and summary measures likewise. So descriptive means we have to collect data and we have to arrange. That's it. So there are different types of arrangement. These are arrangements, no? These are arrangements. So ungrouped data distribution, group frequency distribution, ungrouped frequency distribution, so on we can arrange. And after arranging them, we can sketch different graphs, histogram, frequency polygon, ogive. Likewise, we can further arrange, represent data using graphs and tables. Then inferential statistic. Okay, so then we have to make decisions. Using statistic. So under A levels, we don't have anything like that. We don't have data collection, we don't have data arrangement, we don't have data analysis. All we don't have, but we have only calculation part only. Okay. Then I told you there are two different data types, qualitative variables and quantitative variable type, qualitative and quantitative. Then with quality, it represents qualitative data, and likewise quantitative data we have. So further we have quantitative data. See this one now. So if you have quantitative data, you consider weight. So 55 kilograms. So if you round to integer, this is we call discrete data. 55, 56, 37, 34, 42. These are we call discrete data. If we round up to 1 kilogram, then we call that is discrete. So you consider here weight of student that distribute from 30 kilograms to 100 kilograms. Here the range now. Here the range of that data. So within that range, there's a student of 45 kilogram. And there's another student 52 kilogram. There's another student 60 kilograms, so on. So I have here round to 1 kilogram. So exactly 52, not exactly 52, sometimes that can be 52.25, but we can round it now 52 kilogram. Then if we consider that special values, we call that is discrete data. Then numerical data, we have one is called discrete, and there's another one we call continuous. So you consider weight, actual value. So 55.2656 kilogram, 37.1125 kilogram. These are actual figures. Therefore, same weight we can consider within 0 to 30 to 100 with full figure here, we can say that is continuous. So if you consider only few selected elements within that region, that is we call discrete. Then as according to our thinking pattern, we can say is that discrete or is that continuous data set. Okay, that is about numerical data. Okay, now by the side write down go to page number 2. So you better write there, put star mark and write there. Top of the page first write. Just collected data of an experiment. Just collected data of an experiment is known as raw data. Okay. Now there are page number 2 given data recorded in the sequence in which they are collected and before they are processed or ranked, called raw data. Okay, just collected data. So it don't have any pattern, no? Thereafter we can arrange it. So after arranging ascending or descending, we can say that is data array. Then that data array we call ascending order arrangement. Then data array by the side write down. By using data array, it is easy to obtain highest element, comma lowest element, comma range, comma median, comma quartiles, okay, put some dots, huh? Okay, now let's move a little further. Then first thing, raw data. Then after arranging, we can consider data array. So now after arranging, we can analyze. There are 240, there are 241 and 244, 248, so on. No? We can analyze that. Then with that element, we can analyze their frequencies. No? Then we can get that into table. We can further arrange that. So that arrangement we call frequency table. Then that has mentioned in below. Then entries 3 tally mark 1 frequency 1. So on I, then 10 tally one I, then frequency 1. So on we can arrange, no? Okay, let's move further. Let's move further. Then thereafter we can further arrange into a table. So that is we call frequency table. Okay, let's do this way. Here we call class intervals. And you consider frequency. Usually we denote by Fi. Then 0 to 10, 0 to 9, then 10 to 19, 20 to 29, then 30 to 39, and so on. Let's stop here. Then frequencies, let's say 5, 10, 20, and 10. So these are frequencies count. Here this is we call grouped frequency distribution. So this is class interval, but when you consider class interval, here 0 to 9, then 10 to 19, there's a gap here, 9 to 10 we have gap. So if you consider class interval, here 0, 9, then 10 to 19, here we can see a gap, no? Here there's a gap. Here 19, then start from 20, then 20 to 29. Here there's small gap here. Therefore, these are not real boundaries. So this midpoint will be a boundary. This is we call real boundary. Here midpoint will be real boundary. Therefore 9, 10 midpoint 9.5. 10, 20 midpoint here 19, 20, here 19.5. That is real boundary. Therefore, if you see this type of table, then you have to make real boundaries. Then here gap 1, then divide into 2. Then 0.5 you put here, another 0.5 you reduce here. Then here 9.5, here 9.5, 19.5, then 19.5, 29.5, then here 29.5, 39.5, and here minus 0.5. This is we call class boundaries. So if you need to find class width, here you need to consider class boundaries. By this you find class width. 10. Not from here, but you have to take real boundaries. This is we call class width. 29.5 to 39.5 we have 10. Okay. Don't take this one, you take this one. Then 0 to 9 we have 5 count, no? 5 count. But we don't know what's the value here. 5, is it 10, is it 4, is it 6? We don't know what is it. But we consider here class mark, we call xi. So here I'm going to say 0 to 9, 5 count, I'm going to consider mid value is the class mark here. Then 0 plus 9 divided by 2, 4.5. 10 plus 19 divided by 5, 19 divided by 2, 14.5. Okay. Then here 24.5. Here 34.5. This is we call class mark. Here this class represent by 4.5. Here this class represent by 14.5. This class represent by 4.5. Then we consider there are 5 elements with 4.5. We consider 10 elements with 14.5, 20 elements with 24.5, and so on. This is we call group frequency distribution. Group frequency distribution. Okay. Then we have to analyze that one further. Now this is frequency now. That is frequency. So when we add frequency, adding frequency very important thing. So when we add it, we call that is cumulative frequency. We denote by capital F. Cumulative frequency. So we have F greater than and further we have F less than. Increasing cumulative frequency, decreasing cumulative frequency. This is it. You take 5 here, then 5 plus 10, 15, 15 plus 20, 35, 35 plus 10, 45. That is increasing cumulative frequency. Increasing cumulative frequency. That means frequency addition from lowest to highest. Then reverse order, you put 10 here, then 10 plus 20, 30. 30 plus 10, 40. 40 plus 5, 45. Here increasing cumulative frequency and here decreasing cumulative frequency. These are some words, technical words. So this is about group frequency distribution. Group frequency distribution. Okay. Now go to page number 3, frequency distribution. Just read it first. Those are things I mentioned in here. Frequency distribution. Data represented in the form of frequency distribution table are called group data. Here this is group data. Okay, this is frequency distribution. A class is a non-overlapping intervals. So this is non-overlapping intervals. They are different intervals. And it has class width and each class consists of 2 numbers and so on. You just read it. Then last point, class limit 30 to 35, 36 to 40, then class boundaries. So here these are real boundaries. These are class boundaries. Then from that boundary we have to consider class width. So next page, class width upper boundary limit minus lower boundary limits. That is class width. Okay. That is frequency distribution. Okay. Now page number 4. Page number 4. You have a table, no? You have a table. Okay, now you same space, you extend the table. Huh? You extend the table, same space. Here, do with me, class limit. Do with me, 60, 70, 70, 80, 80, 90, 90, 100, 100 to 110, 110 to 120, 120 to 130, 130 to 140, 140 to 150. Here frequency, here there are small gap, no? So within that gap, you put xi, and label it class mark. You find class mark is the mid value, 65, 75, here class with 10, no? Then 10 by 10 you add, 65, 75, 85, 95, 105, 115, 125, 135, 145, do with me. Then frequencies are given, so within bracket, you better to put F5, within bracket put F5. Then 25, 100, 150, 200, 240, 160, 50, 40, 35. Do with me. Now extend this table, f greater than, f less than, and you label here increase in cumulative frequency, here decrease in cumulative frequency. Do with me. Here increase in cumulative frequency, decrease in cumulative frequency. Find them. Take addition. 25, 125, 275, 475, 600, 715, 875, 925, 965,000. That is increasing cumulative frequency. These are important. Later we will see why we calculate these. Then decreasing cumulative frequency, you start from lowest here, 35, 75, 125, 285, 515, 25, no? 525, 625, 775, 35, 75, 125, 300. 625, 825, 35, 75, 125. Five, 7, 8, 9,000. Okay. Here decreasing cumulative frequency, increasing cumulative frequency. Okay. Now later we will use that. Later we will use that. Okay. Then what is class mark? What is class mark mean? Here this is class mark. So we consider this class represent by 65. Then mid value of class limits. So this can be class limits or this can be class boundaries. Whatever it is, okay. Mid value won't change, no? Mid value won't change. Within by using class boundaries or by using class intervals, you can find class mark. So that's the mid value of that class. What is cumulative frequency? Then cumulative frequency means frequency addition, no? Frequency sum. And there's another special word called relative frequency. Relative frequency. Here, the frequency of this body, that is 1,150, no? Then total 1,000. Total. Then relative frequency of class 90 to 100, 90 to 100, 80 to 90, yeah? 80 to 90. So relative frequency means total frequency 100, total frequency 1000, then 80 to 90 frequency 150, no? 150. Then this is we call relative frequency. Then frequency divided by total frequency. Frequency divided by total frequency we call relative frequency. Later we will see why we use relative frequency. Because we have to use that. There can be some classes with different width. Here these widths are same, no? There can be some classes with different width. For that case, we have to consider about relative frequencies. Relative frequencies. Okay. Now with this table, let's start sketching few graphs. Okay. Now here graphs we have histogram. Second one, frequency polygon. Polygon. Third one, ogive. So in ogive we have two things, increase in cumulative frequency graph and decrease in cumulative frequency graph. Let's try to sketch them because we need them. Okay. Now you use same table. So next page you have space now. You have space. So that's program, no? You consider this table. You can consider this table. Huh? Okay, do with me. Under histogram, here you mark class intervals. Here start from 60 now. Then here 60, 70, 80, 90, do with me. 100, 110, 120, 140 and 150. 150, and here you have to get another class before 60, 50, you start from 50, yeah? And also you better to get another class after this, 160, then stop. This is class boundaries. You have to consider class boundaries. Okay, not class intervals, huh? But here class interval and class boundaries both are same, no? Here this example, class boundary and class intervals both are same. But when sketching histogram, we have to consider about class boundaries. We can't put any gap here. We can't put any gap, okay? Now there this will be frequency. This will be frequency. We sketch only one graph, huh? We sketch only one graph. Now 60, 70, 25, do alone. Then 100, then 150, 200, 240, 160, then 50, 40 and 35. This is histogram. Okay, here this is histogram. Okay, with the frequency you sketch. Later we will need this to obtain mode, and we have to consider about shape using this histogram. Likewise, we have to analyze dataset using this graph. So thereafter you consider mid values here. These are class marks. No? Here these are class mark. Mid value class mark. Then you join them. You join them using a line. Then here this class mid value, you join it, and here also you have to join. Something wrong here, no? Here 60, 60, 70, 80, 90, 100, 110, 120, 130, 100. It is okay. Then here 50, mid value you mark it. Here this is called frequency polygon. Frequency polygon. Just do. Just do. Then here this frequency polygon, we can smooth it using, you sketch it freehand thereafter. This is smooth frequency polygon. You sketch freehand. Huh? So that is data distribution. So previously 60 to 70, here frequency, no? We know that we don't have any figures here, no? 60 to 70, we don't have figures. That's why we sketch using sketch freehand. Smooth frequency polygon. Polygon. The previous one line sketch, here frequency polygon. Frequency polygon. Okay, here I have sketched this for equal class intervals. Equal class intervals. There can be different class intervals. For such case, we have to consider relative frequency. Okay, later we will see that. You complete up to that. Okay, here this graph very important. Na? Here this frequency polygon, smooth one, that is very important to analyze shape of the distribution. So in our A-level question also we have to analyze shape, skewness. Okay, later we will analyze it. Then here histogram, here tallest one, no? Then this class we call model class. Model class. Frequency, here highest frequency, no? Then highest frequency class we call model class. You better write it. Model class. Highest frequency. So we consider mod lie in between 100 to 110. Highest frequency class. That is we call model class. Model class. Then using this histogram we can take that. And using frequency polygon, we can consider shape of the distribution. By this, I write down, by using frequency polygon, it is possible to analyze shape of the distribution. By frequency polygon, it is possible to analyze shape of the distribution. Shape of the distribution. Within bracket, skewness. Shape means skewness. S-K-E-W-N-E-S-S. Skewness. Skewness. Okay, that's about histogram and frequency polygon. Huh? Okay, now let's move further. Now, here there's another graph. That is another special one. We call ogive. We have two different cases: increase in cumulative frequency graph and decrease in cumulative frequency graph. Here we have increase in cumulative frequency. No? You consider here this column, and with that you consider upper limit. You consider these two, upper limit and increase in cumulative frequency. By that we can sketch increase in cumulative frequency graph. Here the way, yeah? Increase in cumulative, before that let's sketch it, later we can label. Here this is class interval, or better to say class boundaries. Here you put cumulative frequency, capital F. Don't put simple F. That is cumulative frequency, capital F. Now here classes start from 60, no? 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay, you better to get another class before that, 50, and cut here. Now, with this upper limit, 70, no? 70 plot with 25, 70, 25, 80, 125, 90, 275. You plot it. Then here 70, 25, 80, 125. 90, 275, and so on. You can sketch 475, 110, 715, 120, 815, at 875, 925, then 965, and so on. You can sketch. Then here you sketch it. Then this is called increase in cumulative frequency graph. Then you have to join this one to here. Here this class upper boundary, no? Then its lower boundary you have to put. That's how we sketch increase in cumulative frequency graph. Okay, sketch somewhere. Page number 5, you have to sketch very small. Sketch it. Increasing cumulative frequency graph. You have to consider upper boundary with increase in cumulative frequency. Na? Then it is just like here S shape. So here is smooth one. Okay. Then total one it count will be 1000. Here this count will be 1000. Then here 500 will be mid value. Then here this element we call median. Median. Here total count 1000. Then middle one 500. Then 500 corresponding value will be median. That's how we find median. Then using increase in cumulative frequency graph, we can find median. We can find median. අතන ස්පේස් මදි නම් වෙන කොලයක හරි දැනට අඳින්න. Yes, sketch. Increase in cumulative frequency graph, upper boundary with frequency f greater than. Upper boundary with f greater than. Decrease in cumulative frequency graph, lower boundary with f less than. No? Lower boundary with f less than. Increase in cumulative frequency graph, then lower boundary f less than. You sketch it. So when you sketch it, it goes on. You stop at 40. You sketch according to scale. Here decreasing cumulative frequency graph. Take time, take time. Here increasing cumulative frequency graph, you consider upper boundary with f greater than. Decreasing cumulative frequency graph, you consider lower boundary with f greater than, sorry, f less than. So here you have to go another point, that is 150. Yeah? 150, you have to stop here. Then that interception point will be median. Okay, sketch them. Anyway, you identify. To sketch increase in cumulative frequency, you have to consider upper boundary with f greater than. To sketch decreasing cumulative frequency graph, we have to consider lower boundary with f less than. Take time and complete. Now close to this chart, you better to write by using Ogive, median can be obtained. By using Ogive, median can be obtained. Median can be obtained. Okay. Now come to here. That is very simple now. Then no need to worry about sketching further graphs. But there's small specialty. Now page number 5, there's another table, no? There's another table. Page number 5, there's another table. So when you see that 10, 15, 15, 20, 20, 25, 25, 30, 30, 35, 35, 40, 40, 50. Now class width has changed, no? then 50 to 70, 10, 20, 69, 64, 47, likewise. Then you go to the table class boundary. Here x 10 to 15, here right side closed, left side open. 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 50, 50 to 70. So this is somewhat special because class width are different. Then here frequencies are given 10, 20, 69, 64, 47, 23, 12 and 2. So here by the side you better write down different class boundaries. Different class boundaries, okay? Then here you need to consider relative frequency. Relative frequency. Here class width 5, no? Now check this. Here 5, 5, 5, 5, 5, 5, 10, 20. Here ratio 1, 1, 1, 1, 1, 1, 2, 4. Here 5, no? Up to here class width 5, but here it has doubled, no? Here ratio 1 to 2. Here times 4. Then ratio 1 to 2 to 4, no? Class width ratio. Therefore, when you get in relative frequency, so you don't change. This is majority part, no? Majority part. Therefore, don't change that. 10, 20, 69, 64, 47, don't change. And this one, 23, don't change. But relative frequency means here class width had doubled, no? Then this frequency must be divided by 2. Then 12 divided by 6. Then we call this is 2. That is relative frequency. That is relative frequency. So here doubled, therefore frequency you have to get divided by 2. Here times 4, no? Then you 2 divided by 4, half. This is relative frequency. Then when sketching histogram, you have to consider that. When sketching histogram, you have to consider that. Not for ogive, but for frequency polygon, you have to consider that. Okay, you put that one in the table. Twelve over 2, 6. 12 over 2, 6. Here times 2, then 12 divided by 2, 6. Here times 4, then 2 divided by 4, half. Identify histogram and frequency polygon will be affected with different class boundaries. Okay, but ogive that won't affected. Only histogram and frequency polygon will be affected. So when sketching histogram, you have to consider relative frequency. You have to consider relative frequency, not frequency. Yeah? But for same class intervals, relative frequency and general frequency both are same, no? For same class intervals, frequency and relative frequency both are same. But for different class intervals, so we have to consider relative frequency. Relative frequency. හරි. ඔතන ඔය සයිඩ් එකේ තියෙන චූටි ඉඩහරි කමන්නේ පොඩ්ඩක් ඒක යූස් කරලා හිස්ටෝග්‍රෑම් එක අඳින්න. 10 to 15, 10, 15, 20, 25, 30, 35, 40, 45, 50, here 50, 55, 60, 65, 70. Then 10 to 15, 10, 20. Yeah, you have to get relative frequency. Then 69, 64, 47, 23. Then you have to sketch 2, 6. Here 2 classes. Then 50 to 70, half. Here 4 classes. 4 classes. That's how it affected. Huh? That's how it affected. So in this histogram, there's a tail, big tail. Yeah, that's big tail, no? Then you join midpoint. So this is special. Here we have 2 classes. You consider this like 2 classes now. So first class midpoint and second class midpoint, same horizontal level. Now when we sketch it, it's look like here a horizontal line. Here there's horizontal line. Don't get mid value of 40 and 50. You have to consider 40 to 45 mid value, 50 to 45 to 50 mid value, and do same. Then each class you get midpoint. That is how it is affected. That's how we sketch frequency polygon and histogram for different class boundaries. Different class boundaries. So somewhere close to this table, just write a line. Histogram and frequency polygon will be affected for different class intervals, right? Close to this table, just write. Histogram and frequency polygon will be affected with different class intervals. Histogram and frequency polygon will be affected for different class intervals. Now see this. Now here we are. Here we are. Now initially we had a population. We had a population. That is the collection that we need to do our practical. So with the capacity we can select full population, or with the capacity we can select sample. So we have to think and select that. Okay, with the capacity we can select. So we do some practical and we collect data. Usually we consider about numerical data. Then for calculation we need numerical data. So after collecting data, then we have to arrange them, arrange in data. Arrangement, just collected data I call raw data. Then initial arrangement ascending order arrangement. That is we call data array. Then that data array, ascending order or descending order, whatever it is, okay. So by arrangement, different arrangement, we can analyze different manner of that data set. No? So ascending order arrangement, it is very easy to say lower value, higher value, and range, and mid value, and quartiles, and so on. Okay. Then if we have a huge data set, we have to rearrange it. No? We have to rearrange it. Therefore, we have three different arrangement type. I told you one, it is like x1, x2, x3 like xn, just line arrangement. That is we call ungrouped data distribution. Then second one, x1 frequency f1, x2 frequency f2, x3 frequency f3, and xn frequency fn. Here this arrangement we call ungrouped but frequency distribution. Then third arrangement, for large data set, we have to rearrange it with the classes L1 to L2 range frequency f1, L2 to L3 range frequency f2, Ln to Ln plus 1 range, here put some dots, frequency fn. Here this is all called grouped frequency distribution. So likewise we have different distribution types. So we have especially three different types in our A levels. Here ungrouped data distribution, we call data, all data there, no frequency. Then ungrouped data distribution, that haven't grouped, no? Then here ungrouped, here x1 frequency f1, no? Ungrouped frequency but frequency distribution. Here it has grouped here. With class intervals we have grouped. Group frequency distribution. Group frequency distribution. Okay. Then each case we have to calculate few different parameters. Okay. Now take your tutorial. Go to last page, 2024 A-level question. See part B. Don't try to do, just see. Just see. That is part B, a table, no? That is group frequency distribution. Part A, 1, 3, 4 PQRS, ungrouped data distribution. Ungrouped data distribution. 23, part B, just see. There's a table. Then group frequency distribution. No? Then go to part A. At set given x1, x2, x10, 10 element given. That is ungrouped data distribution. No? Ungrouped data distribution. Just go to 2022 part B. Here diameter and there's a table given with frequency, group frequency distribution. The mean and the standard deviation of mark, there is something else. Okay. Then so on, you must have capacity to analyze what type of data distribution is given. Usually part B will be group frequency distribution. No? Usually part B section will be group frequency distribution. Okay. Now let's see what are the further part. Let's see what are the further part. Now we have a data set. So now we have a data set. Now statistic mean data collection, arrangement and analysis, but we don't have anything under A levels. But to analyze, we have to calculate some parameters. We have two different parameter getting techniques. One is compression. We're going to compress that full data set and we get that into one point, single point. Like we're going to count average. We call mean. So we have distributed data set. So we add all and we divide by full count, full frequency. Then that value will be, we call mean. So mean only one value, no? Only one value. Mean only one value. Then further, so we arrange our line, we select mid value, we select one mid value, okay. Then we have distribution, we consider highest frequency element, then we have highest frequency element. So those measurements we call central tendency measurements. Central tendency, we tends to one point, mean 1 point, median 1 point, mode can be 2 or 3, but they are also very limited, no? Mode also very limited. Then we tends to 1 point using central tendency measurements. So that is compression format. Thereafter we can expand them. So when we expand, we have lower, we have higher, that gap we call range. Previously compression, now dispersion. Okay, expanding. Then range. So we have first quartile, we have third quartile, then interquartile range. Okay. We have mean, so we have full distribution here. So if you calculate mean, so mean average value. So within that region there will be mean. With that mean, each element gap we can calculate, no? With the mean, each element gap, you consider there's 100 student here, average mark 45. There's special student, he has mark 65. Then that gap 45 minus 65. That gap. Likewise, distribution, expansion type. Then likewise, you can calculate different parameter types. So one is called one measurement called central tendency measurements. Especially we have mean, median, mode. 3 different central tendency measurements. Then thereafter measurement of dispersion. So here we have mean deviation. Here we have standard deviation. Here we have variance. Here we have range. Here we have interquartile range. Likewise, interquartile range. Now take your tutorial again. Go to last page. Just read part B. Just read. Don't think what is given, but just read. Estimate the mean. Last line. Estimate the mean for the code. We have to estimate mean and estimate the standard deviation, mode. Okay. That means we have calculation. We have to find mean, mode, and standard deviation. No? Go to 23 question and read it. Last line. Don't think and just read. Estimate median, mean, variance. Median, mean, variance. Then you compare both sections. Then common, mean, mean is common. Then mean calculation very frequently we have to calculate. Mean calculation. Then variance, standard deviation, there's relation. Standard deviation is the square root of variance. Later I will say. Then go to 2022. Estimate the mean. 2022 last page. Last page top. Estimate the mean, median, variance. You see, we have to calculate always mean and median or mode or variance or standard deviation. Standard deviation, variance, similar calculation, we get similar pattern. Okay, but there are some differences. So just see 2021. So last line, last para by me of transformation, estimate the mean, standard deviation, and there's special one, coefficient of skewness. I told you about skewness, that means shape of the distribution. Then just go to 2020, part B, estimate the mean, standard deviation, mode of the distribution. So identify. So there will be a distributions. So you have to calculate those parameters. So we have 2 different types of parameters. One called central tendency measurements The other one is called measurement of dispersions. Okay, we have to do one by one. Okay, let's see. Okay, you better to get a paper and write this one. Better to get paper and write. I haven't given that one. Population sample, here data collection, here data collection, then arrangement. Arrangement of data. Here the population or by sample you have to collect data. Here collected data. Then you have to arrange it. You have to well arrange. Here there can be graph, no? There can be graph. There can be table. Likewise, we can arrange. Here just collected data, then we have to arrange it. So especially that arrangement has three different types. Put this. Here this type of one, ungrouped data distribution. Here this type of one, group frequency distribution. And this type of one, group frequency distribution. Okay, just write. Okay, now let's move a little further. Now here we have three different distribution type now. So now we're gonna calculate mean, median, mode first. It is very simple. For this one, take highest frequency element as the mode. For this one, you identify the highest frequency element. Here also you can easily identify mode for these two cases. These two cases, really easy to find mode, no? Mode means highest frequency element. But for this case, it is somewhat difficult, no? Because here there's a class, no? Here we have data loss. Here there's data loss here, no? Therefore, we can identify highest frequency class. Within that class, there are entries, no? There are entries. Therefore, we can say which one is the highest frequency element, but we can identify the highest frequency class as the model class. Then we have to think how to select mode from this type of distribution first. Okay, this type of distribution. Okay, now you see, so those are given. Page number 6, last, the mode is the value that occur most often in the data set. Okay. So go to page number 7 now. Mode for group frequency distribution. Okay. So that space you can write this. Initially given, the distribution of data set has choice of following: non-mode, unimodal, bimodal, multimodal. Okay. Now here, don't worry about that. So when you consider histogram, you will see bar chart, no? You will see a bar chart. Then the tallest one we call model class. See, here you say model class. So here you consider here this frequency gap delta 1. You take this frequency gap delta 2. So here lower boundary L1, take this class with C. Class with C. L1, say class with C. Okay. Now see how to select mode. So in that class there are elements, no? Then frequency, that is highest value. But here previous class, here its frequency somewhere here, thereafter it's distributed, no? It has distributed. Therefore you think that distribution happened like this, from here to here. Then here next class we have frequency here. So from here to here its distribution you take like this. Then that intersection point you take this value as the mode. Okay. Then geometrically we can find mode because we can't select actual, we don't have actual figures. Then here, from here, you sketch distribution, and here distribution, then here intersection you take as the mode. Graphical technique. We have graphical technique. හරිද? මේක මේ data distribute වෙනකොට මෙතන ඉඳන් මෙතනට මේ වගේ එකම line එක යන්නේ නැහැ නේ. මෙතන මේවා ටිකක් තියෙනවනේ එක එකක් ඔහම frequency වෙනස් වෙලානේ තියෙන්නේ. Then you have to do that way. Now when you consider this triangle and this triangle, so these are similar type triangles, no? Similar. Then delta 1 divide by delta 2 equal, here delta 1 divide by delta 2 equal, here this gap MO minus L1. MO minus L1. Here this coordinate MO, this coordinate L1. Then gap MO minus L1. Divide by, here this gap, no? Here this one. Here coordinate L1, here class with C. Then this coordinate will be L1 plus C, no? Here this coordinate L1 plus C, this coordinate MO, then gap will be L1 plus C minus MO. Okay. Here similar triangles, delta 1 divided by delta 2 equal, here MO minus L1 over, here L1 plus C minus MO. Now here MO is the mode, delta 1 frequency gap, here frequency gap, L1 mean model class lower boundary. Model class lower bound. Let's see how to get that one actually. Yeah? This is the proof. Now cross multiply delta 1 L1 C minus MO, delta 2 MO minus L1, then subject MO, take the other side delta 1 plus delta 2 C, here L, delta 1 plus delta 2 C delta 1. Now subject MO, divide by delta 1 plus delta 2, here L1 plus C, delta 1 over delta 1 plus delta 2. So we use this formula to calculate mode for group frequency distribution. Okay. We use that equation to calculate mode for group frequency distribution. This one. හරිද? එතකොට ඒකේ කේස් එක තියෙන්නේ මෙහෙම එකක්. දැන් ඔයාලට මේකේ මේ distribution එක යනකොට මේ උස වැඩි class එක තියෙනවානේ. උස වැඩි class එකේ කවුද කියලා දන්නේ නැහනේ. කවුද කියලා දන්නේ නැහැ. හැබැයි මෙතනින් මේකේ start වෙනවා කියලා අරගෙන මේකේ end එක මෙතෙන්ට අරගෙන මේ විදිහට line එකක් ගහනවා. ඒ කියන්නේ මෙතන ඉඳන් මෙතෙන්ට class එකේ data distribute වෙනවා කියලා linear විදිහටම. මෙතන class එකේ end එක මෙතන, start එක මෙතන. එහෙනම් මෙතන start එකේ ඉඳලා line එකකුත් ගහනවා. ඒතර මේක අඩු වෙලා යන distribution එක මෙහෙම කියලා ගන්න. ඒ දෙක common කරගෙන තමයි cut වෙන point එක ගන්න. ඒතර ඒක තමයි මේක represent කරන එක. මේක මෙයාගේ mid එක අපි ගන්නෙ නැහැ. අර කලින් වගේ mid එක අපිට ගන්න බෑ. අර මේ class mark එක ගන්න බෑ mode එක කියලා. ඒ විදිහට තමයි mode එක ගන්න. Okay, do that calculation there. You have space now. Page number 7, mode for group frequency distribution. You did this say. You do this way. Get that proof? Okay. So that space you better to write highest frequency class is the model class. You better write there highest frequency class is the model class. Put another star mark and write down. Another star mark and write down. When using formula, when using formula, the data arrangement must be ascending order. The data arrangement must be ascending order, not descending. That must be ascending. Okay. Now see, very simple calculation we have. Let's do few. Take your tutorial page number 10, 2000 A-level section. 2000 A-level section. See that? Don't do, just see. So a table given, the top 95 to 99, down, bottom 50 to 54, no? Then descending order arrangement. Then you have to swap it, okay? So before doing the section, you have to swap it. You have to arrange it ascending order. Then 2001 ascending order, then all ascending order thereafter. 2004 ascending order, 2005 ascending order, and 2013 ascending order, 15 ascending order. Likewise, all the others are ascending order distributions are given. Then before 25 years, so descending order distribution has given. So if this a descending order distribution given, definitely have to arrange that into ascending order first. Okay. Now go to 2003 A-level section, 23 section, 2023. Let's calculate mode. Okay. Now do this here. Do with me. Don't get the table. You don't sketch it. But here 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Don't read the section. Here frequency Fi 10, 20, 35, 20, 15. So I'm going to calculate mode. We know the equation MO equal L1 plus C delta 1 over delta 1 plus delta 2, no? So that is very important to arrange that in ascending order. Now that is given in ascending order, no worries. So you have to select highest frequency class. See, here we can see highest frequency class. You say that is model class. Then it is very simple. L1 mean model class lower boundary. 20. Then C, we know that is class with 10. Delta 1, here frequency gap 35, 20, here frequency gap 15. Take only value, take only magnitude. Then delta 2, frequency gap. Both are 20, no? Then 15. 15. 15, 15, 15, cancel 25. This is the mode, with the mode. That is very simple calculation. That's how we calculate mode. Okay, you go to your worksheet, and put just only year 2023 and just do calculation. So when you are doing calculation, we need one decimal place. Huh? Don't read the question, just calculate mode. That's it. Huh? Later we will discuss and do all the question. First you select model class. Model class means highest frequency class. So L1 mean lower boundary of the model class. C mean class width of the model class. Delta 1 mean frequency difference between model class and class before model class. Delta 2 mean frequency difference between model class and class after model class. So here this gap delta 2, here this gap delta 1. First you arrange ascending order. Then you substitute the equation and get the result. That is mode. Okay. Go to 2022. 2022, just calculate mode. Don't read the question, just calculate. 2022. ඔතනම කරත් කමන්නේ නැහැ. ටේබල් එක ගාම කරත් කමන්නේ නැහැ. 2022. First see what is the highest frequency class. So that is 10 to 14. Here 10 to 14, frequency 8, before frequency 5, after frequency 4. Then MO, L1 mean 10, C class gap width 4, delta 1 here 3, delta 2 4. Then 10 plus 12 divided by 7, you can calculate that into one decimal place. And that is very simple calculation. No? Do 2019. Just do calculation. 2019. Just practice, huh? Don't read the question, just practice. See highest frequency class 25 to 35, frequency 14, before frequency 11, after frequency 10. Here delta 1 gap 3, delta 2 gap 4, here L1 and class width 10. Then mode L1 25, C 10, delta 1 3, delta 1 3, delta 2 4. Then simplify 25, 30 divided by 7. You can calculate that one decimal place. No? Then all the others are same. No? You don't worry about the things. All the others are same. Okay, now you go to 2000 question. 2000 question. So by the side they are write down. By the side write down. It must be you have to arrange ascending order. No? Just put star mark and write down. Arrange in ascending order first. First arrange in ascending order. That is very important. Nah? Otherwise, all the other calculations will be wrong. Arrange in ascending order. 2000 A-level question, by the side write down. 2000 A-level question, by the side write down. Ascending order. Arrange in ascending order. Okay. Now for For now, you don't go to write a table, but you identify highest frequency class, which is the one 70 to 74, no? Then here we have 70 to 74, then class 65, 69, and before that 70 to 70, 65 to 60. 65 to 69, 75 to 79. 79. Here frequency 41, here 38, here 50, here 41, here 38, here 35. No? Now you have to arrange ascending order. You do only this one. Na? Then ascending order arrangement 65 to 69, 70 to 74, 75 to 79 this way. Then here 41, 38, 35. Then this is we call delta 1, no? And this is we call delta 2. Then 41, 38, 3, 35, 41, 6, no? Then descending order, if you take delta 1 as this, delta 2, delta 1 will be different, no? අපිට මේ විදිහට තියෙද්දි delta 1 එකයි මේ විදිහට තියෙද්දි delta 1 එකයි වෙනස්. That's why I told you to arrange that in ascending order. And there's another important thing. Here boundaries are not real, no? You have to make real boundaries. Here there's gap 1, you distribute 0.5, 0.5. Then here 69.5, 74.5, here real boundaries, 74.5, 79.5, you do only this part, 65.5, 64.5, 69.5. Then here this is our L1. Na? This is L1. Then you take class width 5. Class width take from real boundaries, okay? Not with this. Here you have to get real boundaries. Now here class width 5, lower boundary 69, delta 1 3, delta 2 6. Now it is very easy to calculate. No? Now go to formula. MO L1 plus C delta 1 over delta 1 plus delta 2. Delta 1 plus delta 2. Okay. Now L1 means 69.5. C mean 5. Delta 1 mean 3. Delta 2 mean 6. Now you can get the value, no? One decimal place. Then this is very simple calculation, but there's very important thing, ascending order arrangement and real boundary calculation. Otherwise, that will be wrong. Okay, that is very important. Okay, let's do another two only. Let's do another two only. You go to 2005 table, 2005 table, and calculate mode 2005 table. Calculate mode. First you get real boundaries, because real boundaries are not given. Then you get real boundary. Highest frequency class select. Then is lower boundary L1. By class in boundaries you would select class width. You find class width. Then delta 1, delta 2 again select. Then substitute. $44.5 plus 5 times 15 or 15 plus 24, 25. That's how we calculate mode. Take another one table and do soon. 2010. 2010. Do soon. Two 2010. This mode calculation not frequently asking. Usually mean we have to calculate. Usually we mean we have to calculate. Variance or standard deviation we have to calculate. Sometimes it may given mode, median, okay, skewness, coefficient of skewness, so on. Mode very rare, usually rare calculation, but in 2024 for there's mode, no? 2024 mode we have to calculate. 2023 median given. Then median mode not rare, then always will be there, but mean and standard deviation or variance will be there definitely. Okay, 2010. Real boundaries are given. Highest frequency element 38 frequency, no? Then mode 40 plus 10, 3 plus 8, no? So you have to take for one decimal place. For now, no need, but when you are doing calculation, you have to take that into one decimal place. Okay, now here we are. So initially we have identified statics mean analysis about data. Then to analyze that data, we have to first collect, then arrange, then analyze. Then we can't just analyze, then arrange data we can analyze for some little level. But further deep analysis we do by using parameters. Then there are different type of parameters. So by compressing that, we consider about central tendency measurements. So mode is one of that. Median is one of that. Mean is one of that. Those are central tendency measurements. Okay. Then thereafter we expand them. By expanding, we consider about another new parameters like range, like quartile deviation, like mean deviation, like variance, like standard deviation, so on. Okay. So that is another parameter type. By considering all, finally we analyze full data set. That is statistic. Okay. Okay, let's have a small interval. Okay, now let's start. Now we know all the things about mode, no? Then for ungrouped data distribution, we can count and we can select the mode. For group ungrouped frequency distribution, frequencies are given. Therefore, with the frequency, you can select the mode, no? Now here group frequency distribution, for group frequency distribution, we can calculate the mode. We have to calculate that, huh? But the previous distribution type we can select. Now let's see what is median. Okay, see this one now. See this one. Now median also very simple thing. So it has defined ascending order distribution mid element. Ascending order distribution mid element we call median. Median. Okay, now you consider ungrouped data distribution. Ungrouped data distribution. Here take 1, 2, 3, 4, 5, 6, 7. Now here odd element, odd number of elements now. Here, here, here. This is the mid value. Then median we call 4. Very simple. Median is 4. Then 1, 2, 3, 4, 5, 6. Here even number of elements. Now you consider there are two midterms now. Now here we have two midterms. So when calculating median, when getting median, you have to get mean value here. Then here median we say 3 plus 4 divided by 2. 3.5 is the median. Then for odd number of terms we have one median. For even number of terms we have two mid values now. Then get mean value of that. That is the median. That's the median. Then you consider x1, x2, x3, here ascending order distribution xn, here say n odd. Then median, here odd no, n plus 1 divided by 2th element. Here we have 7 no, 7 plus 1 8 divided by 2, 8 divided by 2 4. 1, 2, 3, 4. Here 4th element is the median. No? Then if n odd you say n plus 1 divided by 2th element, you select that element, that is the median. So if we have n odd, n even, so here this is the case. Then here 6 no, 6 divided by 2, 3, 1, 2, 3, then next one 4. Then n divided by 2th element and n divided by 2 plus 1th element, get average value. Then here median, n divided by 2th element plus n divided by 2 plus 1th element divide by 2. That's the median. Okay, that's the definition. Okay, that is very simple definition. So if we have ungrouped frequency distribution, here ungrouped data no, then ungrouped frequency distribution, you can follow same technique. Okay, first you write this. So you have space, page number 6. Page number 6, that is given. If n is odd, the median, the measure of central tendency that represent the middle term of the ranked data set is called the median. For ungrouped data distribution, so within that small space, if n is odd, median n plus 1 over 2th element, n is even, n over 2th element plus n over 2 plus 1th element. Divide by 2, that must be divided by 2. N over 2th element plus n over 2 plus 1th element divided by 2. Okay, that small space you write this example. So you correct that, this one. For n is even, divide by 2, right? Now this is the challenge. Now we have group frequency distribution. So for ungrouped data distribution, we can easily find mid value. For ungrouped frequency distribution also, we can easily find mid value. But for that type of group frequency distribution, it is somewhat difficult. Somewhat difficult. So let's see how to calculate that. Then that is obtained by Ogive. I told it before. So see, median for group frequency distribution. group frequency distribution. See this one. Now let's sketch cumulative frequency graph. So you can select increase in or decrease in, whatever it is, okay. I'm going to select increase in cumulative frequency graph. Okay. Here class boundaries, here cumulative frequency. So that graph something like this shape. Here how it is going. Then frequency addition here, then total frequency, let's say n. Total frequency n, here capital F. So here there are classes here, no? There are classes. So the mid value is n divided by 2. N divided by 2. You sketch a line and get pre-image of that. This is the median. This is the median. So graphically you can find median, okay? So after sketching, graphically you can find median. But when you are calculating, let's make an equation. So this median that belongs to a class, no? Here this median belongs to a class. Here this is median. Then this class we call median class. I'll say how to obtain that. Huh? We call that is median class. If you think that there are total frequency 100, then mid value will be 50, no? Then 50th element class, that class will be median class. Okay, now here this lower boundary, take L1. L1. You take this class with C. C. Then here cumulative frequency mean frequency addition, no? Frequency addition. So 1 by 1 we have to add frequencies. Then here median class, no? Then class before median class, all frequency sum given here. Let's denote that one by FC. Then we have to add. Then here median class, then corresponding this one we call median class frequency. We call FM. Here median class frequency. Here FC mean here median class, no? Then before classes frequency sum. Frequency sum. Here median class lower boundary. Here this is median. We usually denote by ME. Mod we usually denote by MO. Now here class with C. When you consider this triangle, now you can say this is similar triangle. But this is not a triangle, but you consider this one as triangles. Then here FM divided by C equal, here this gap n over 2 FC difference, no? N over 2 minus FC divided by here this gap ME minus L1, here ME, here L1, ME minus L1. Then subject ME, that's it. ME minus L1 C n over 2 minus FC divided by FM, then finally median will be L1 plus C n over 2 minus FC divided by FM. This is we call median. Median. Okay, like mode formula, you can remember this one. That is median formula. Then we can, then later we will see how to apply this one. Okay. Okay. Write it. So page number 6, there's space for group frequency distribution. So within that space, you sketch this diagram or give increasing cumulative frequency graph and do that proof. Here L1 we call lower boundary of the median class, C class width of the median class, FM frequency of the median class, FC cumulative frequency up to median class, not with the, up to median class. Okay. Now see one calculation. Take 2023 question. Okay, first don't read the question. Don't read the question, see calculation. Here 0 to 10, 10 to 20, first see this. 20 to 30, 30 to 40, 40 to 50. Here frequency Fi, 10, 20, 35, 20, 15. Here 35, 45, 50, 90, 100. Total 100, no? This is n. See the procedure. Here total count. Now the mid value, n divided by 2 take n divided by 2. 100 divided by 2, 50. Now you have to count 50th element. I'm going to write capital F greater than, then 10, 30, 65, 85, 100. No? Then here we have up to 30. Then here we have up to 65. Then 50th element in this class. 50th element in this class. And we call this is median class. So we wrote f greater than previously now. We wrote f greater than previously because we write that one for easy calculations. Then we can easily see now. Then here 50th element on this class, that is in this class. Then you get median equation L1 plus C n over 2 minus Fc divided by Fm. Then very simple. This is L1, then here gap is C, then L1 20, C mean 10, n divided by 2, 100 over 2, Fc. So this is median class now. Then up to median class frequency sum. It is here 30, or otherwise you add these two, 30, then you get 30. Divide by Fn mean here median class frequency. Fm, that is 35, no? Here this is Fc. Then you can calculate this. 20, 10, 20 over 35, get that into one decimal place. Then very easy calculation for median again. Okay, do it. Here total element 100, n divided by 2 mean 50, get f greater than, then 50th element within this class, then take that class as median class, then get that formula and substitute. L1 lower boundary of the median class, C class width of the median class, Fn frequency of the median class, Fc frequency sum up to median class. Substitute, get the value. Simple calculation. Here these parameters are very simple to understand. So very simple mean median mid value, mean mean average value, mode mean highest frequency. Then those parameters very easy to understand. That is advantage of this type of parameters. But there are some parameters we can't easily understand. Standard deviation, we can't easily understand. Variance, we can't easily understand. Okay. Do that. So in that 2023 allocation, we have to estimate the median. Then very simple mark, no? Very simple mark. Then let's do few questions. Go to 2022. Don't read. Do calculation for median only. 2022. 2022. Do it. 2 6, 6 10, 10 14, 14 18, 18, 20 22, 22, frequency 25, 84, I 1. Better to get capital F greater than 2 7 15 19 20, no? Then total frequency 20. Then 20 divided by 2 10, and 10th element come to here this group class, median class. Then take formula L, median equal L1 plus C n over 2 minus Fc over Fm. Then relevant data you put there. L1 10, C4, n over 2 20 over 2 Fc, take frequency sum up to here 7, Fm 8. Then you calculate. Then surely this value will be within this range. So median must be in that range now. Then similarly previous mode also in between selected class, in between in the selected class. Okay. Then here median class is 10 to 14. Therefore here this value must be in between 10 to 14 value. 10 to 14 value. That is the median. Okay, let's do further few. So you do 2019 one. So like mode, here this is very important to arrange in ascending order. So these all are given in all are ascending order, then here no worries. We can directly get the formula. So if we don't have any real boundaries, then we have to take that real boundaries first. Thereafter you take the formula directly. So like 2000 A level question, you have to arrange in ascending order. Thereafter you have to get real boundaries. Both you have to do. Then thereafter you can do calculations. Practice well. 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55. Then here frequency 9, 11, 14, 10, 6. Then better to get F greater than column 9, 20, 34, 44, 50. Then here addition 50. ME L1 plus C n over 2 minus Fc over Fm. Then you select median class 25th element. Then that come to here. Then this is median class. Then take the properties L1 25, C class with 10, n over 2, 50 over 2, Fc get sum up to this 20, Fm median class frequency 14. Then very easy, no? Then finally you get 1 decimal place. 1 decimal place is enough. Let's do another one only. Go to 2000. Go to 2000. if you can do in your mind, you can do the following table. 200 electric bulbs now, then 200 mean n, then 100 you count 7, start from lower one down, below one. Here 3, 7, 10, 25, 58, 63, then 70 to 74 class is the median class. 70 to 74 class is the median class. Then its frequency 41. Then real boundary, make real boundary 69.5, 74.5. Here L1, C5. Here FM. Then up to that sum 10, 25, 63. FC 63 now. Then median L1 69.5, C5, N over 2, total 200 now. 200 divided by 2 minus FC 63 divided by FM 41. Then that calculation really simple. Mode calculation, median calculation, really simple. Just do another one. 2001 question. 2001 question. Do it. Okay. That's enough for median. Now let's move to mean. Now all are same procedure, no? Then the beginning, you have to see whether it is given ascending order or descending order. So if it is given descending order, then you have to arrange that in ascending order. Then next you have to check about the classes, whether it is given real boundaries or not. So if it is not given real boundaries, you have to find it. Thereafter, do it, do calculations. Okay. Then from the beginning, you check about distribution type, no? Ungrouped data distribution, ungrouped frequency distribution, grouped frequency distribution. There are 3 types. Then for mode and median, ungrouped data distribution, ungrouped frequency distribution, very simple. Without calculating, we can directly find median and mode. But for group frequency distributions, mode and median, we have to get by calculation, no? Get by calculation. Okay, now mean. Mean average, okay? So here you have space, yeah. No. Yeah, you have space in page number 6. Page number 6 about mean. Before that, let's see about mean. So in statistic, you will get only arithmetic mean. In a statistic, you will get only arithmetic mean. But there are different type mean. So you consider A, B, C. So arithmetic mean average, A plus, B plus C, let's say x1, x2, x3, x1, x2, x3. And here count there. No? Then arithmetic mean x1 plus x2 plus x3 divided by 3, no? This is equal average. That is simple mean type. Average value, mean. So for in statistic, our statistic also, we have to calculate that type of mean, arithmetic mean. But further we have geometric mean. We have geometric mean. So here we add all and divide by 3. For geometric mean, we have to multiply all. then x1, x2, x3 and get 1/3 power. Then here square, here cube, no? Then we have to get 1/3 power. This is geometric mean. Here there's property between arithmetic mean and geometric mean. So here arithmetic mean always greater than or equal geometric mean. So we done that under inequality lesson. Arithmetic mean greater than or equal geometric mean. So there's another one, harmonic mean. Harmonic mean. Then we say 1 over harmonic mean equal 1 over harmonic mean equal 1 over x1, 1 over x2, 1 over x3 divided by 3. You take each term reciprocal and get average, that is the reciprocal of harmonic mean. 1 over harmonic mean equal 1 over x1, 1 over x2, 1 over x3 average value. So if you have n number of terms, you have to add all, divide by n. If you have n number of terms, multiply them, get 1 over n power. Here 1 over x, 1 over x2, likewise n divided by n. This is n3. And here especially there's another one we call weighted mean. Weighted mean. Weighted mean. Here harmonic mean. Here geometric mean. Here arithmetic mean. It is something like this. It is something like this. So you see, here you think there's an interview. So we have to select some person with highest average mark. Chemistry, physics, maths. Highest average mark person we have to select. Then chemistry, physics, maths. So 30, 45, 40. Then you can easily count average. No? Then arithmetic mean 30 plus 45 plus 40 divided by 3. No? Likewise, you calculate that, then select highest average person. Then you think again, we have to select one person, we have to prioritize maths. We have to prioritize maths. So let's see, then priority, let's say 1, 1, 2 priority. So just consider here weights, we have to more consider about maths. Twice than physics or chemistry. Here 1, 1, 2 ratio. We have to prioritize this one ratio. These are we call weights. Weights. It's look like frequencies. Then here weighted mean. Here 30 we have 1. Here 40 we have 1. 40 we have to multiply by 2. Then 30 times 1, 45 times 1, 40 times 2, then total weights 1 plus 1 plus 2, 4. No? Then this is weighted mean. So we have to give a weight for 1. So if we need to prioritize 1, we have to calculate weighted mean. Then arithmetic mean, simple mean type. We consider only about average. Then weighted mean, we can prioritize one thing. We can consider weights first, then we can calculate. Then here 1 to 1 to 2 ratio, 30 times 1, 45 times 1, 40 times 2, divide by 4. So if that is given the weight like 1 to 2 to 3, let's say 4, here weights 1 to 2 to 4. So we have to top priority one maths, then second priority one physics, chemistry weak. Therefore, here you can do 30 times 1, 45 times 2 and 40 times 4, then total weight 6, 7. Then this is we call weighted mean. So same thing. Huh? So you consider here chemistry has written only one time, physics has written 2 times and maths has written 4 times likewise. Then we have to get all 40 times 4. That is weighted mean. These are means. Okay, better write them first, not there, but better write separately. You can write in page number 6, upper space. So the most important one, arithmetic mean. Most important one, arithmetic mean. Okay, just write. So weighted mean will not ask usually, and harmonic mean, geometric mean not comes with statistic, but in quadratic or somewhere we can see that type of relations. But anyway, you have to remember, but for statistics, this is not prioritized one. These 2, 3, not prioritized. Okay. Then again, there are 3 spaces now. For group data distribution, mean, group data distribution, ungrouped data distribution, group frequency distribution, and ungrouped frequency distribution. There are 3. So let's see how to calculate that. Okay. Now, ungrouped frequency ungrouped data distribution. Let's take data distribution first. So it is like this now: x1, x2, x3, x4, xn. This is ungrouped data distribution. No? Then mean, very simple, average value. Usually we denote by x bar. Usually we denote by x bar. Class mark we denote by xi. Frequency we usually denote by fi. Median we denote by me. Mode we denote by mo. Mean we denote by x bar. Okay. Then here x1 plus x2 plus xn, x3 plus xn divide by n. Here this is median, very simple calculation type. Type is very simple, but if we get large values there, then calculation somewhat hard. Method simple. Then here we can denote this one by sigma notation. Here r equal 1 to n. Let's say I equal 1 to n. I equal 1 to n, xi divided by n. This is median, very simple relation. That is group data distribution. Then grouped frequency. First ungrouped frequency distributions. So the type x1 frequency f1, x2 frequency f2, it goes on xn frequency fn. Here this is called group frequency distribution. Then here x bar, we have x1 count f1, no? Then x2 count f2, then total x1 times f1, no? Then here total x2 times f2, it goes on xn times fn, divide by total, here frequency sum, f1, f2, fn, no? In weighted mean also we done this. Weighted mean also we are doing similar thing. Now here sigma I equal 1 to n fi xi. Here this change, no? Fi xi divide by sigma fi. I equal 1 to n fi. Here this formula we use for ungrouped data distribution mean, and this formula we use for group frequency distributions or ungrouped frequency distribution, both we can apply this. Ungrouped or group, whatever it is, okay, this is possible. Okay, just write under that spaces. For group ungrouped data distribution, you write this. Then both ungrouped frequency distribution and group frequency, both this one common. This is common for both. Huh? This is general formula. Okay, here mean, just average. Just average. Huh? So here formula, very simple formula, but for large values, this calculation somewhat hard. This calculation somewhat hard. No? Then consider 1, 2, 3, 4, 5, 6. Then 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. Simple calculation. No? Then 100,023, 200,021. Very large values. For very large values, calculation somewhat difficult. Then with frequency, say here element 53, frequency 4. Element 55, frequency 99. Then we can do, but calculation somewhat hard. Okay. Such case, we have coding techniques. So there's one property in a distribution, data distribution. So those data distribute so closely. Okay, when you consider marks 0 to 100, marks 0 to 100. Okay, likewise, normally data distribute so closely. Therefore, according to that property, this calculation we can take into easy steps using coding method. Later we will discuss that because we have to get that one. So here I'll move to one question here. So you take 2023 A-level question, take 2023 A-level question. So let's see, we're gonna find mean. Let's see, we're gonna find mean, okay? Now 2023 part B question, group frequency distribution. No? Group frequency distribution. That means you have to select this formula. No? You have to select this formula. Then let's do that one using table. Let's do that one using table. Let's see what will happen. Okay, now you go to a new paper. Don't do it here. You go to your worksheet and do it. Do with me. Time taken. Do with me. Here you need small space to get xi. And number of students. Number of students. You better write here F5. We call this is F5. Zero to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 10, 20, 35, 20, 15. Now, okay, now let's see, we need to find mean. Let's see, we need to find mean. So let's get this general formula. Let's get this general formula. We need sigma fi, no? Sigma fi mean frequency sum. We need fi xi sum. Fi xi sum. Then let's see how to do that. You take this table. Now you calculate xi, class mark 5, 15, 25, 35, 45. Then here you take addition 50, 90, 100. Then this is sigma Fi. Sigma Fi. Sigma F, let's say sigma F. Then you need Fi Xi. Take another column Fi Xi. Then multiply 50, 300, 35 into 25. Five, 7, 8. 8, 7, 5. 700, 45, 15. 5, 6, 6, 6, 6, 5. Then here we call sigma Fi Xi, a sigma Fi. Then take addition 665. Then here 0, 13, 90, 8, 12, 19, 25, 3590. Okay, then x bar sigma Fi Xi divided by sigma Fi. Then sigma Fi Xi 2600 over 100. 26 now. So by general formula you can do that. Okay, that is general one. Okay, but if you get some large values here, that calculation somewhat hard, no? Then we have coding technique. We have to introduce assume mean. We have to calculate deviations, likewise so on. Then you better to write that previous page. Go to page number 6. Go to page number 6. So page number 6, the mean part, in that space we have wrote some little things now. So put somewhere star mark, write down. For easy calculations, there are coding techniques. For easy calculations, there are coding techniques. Here, the data set has transformed. Into linear scale. Into a linear scale. Okay, let's see what is that. Here, check this one. Here you consider x1, x2, it goes on. So some mid value you select as assume mean. assume mean. Okay. Usually, see this one. Usually mean that belongs to this region. No? Mean belongs to this region. Usually that close to mid. Not always, but it somewhat close to mid value. Then you better to select assume mean as the mid value. So if you go to here this is the mid value, you better to select assume mean as mid value A. Then we have new variable di, that is equal xi minus A. This is equal deviation. Deviation. Then when you subject xi, that is di plus A, no? You put A other side. Then if you consider bar, x bar, we take d bar plus A fixed value. That's how we calculate mean. Later we will prove how to get it. Huh? For now I'm getting only formula. Deviation. Then there's a special method of coding. So here we introduce yi variable xi minus A divided by C. Then here xi equal Cyi plus A. Then corresponding x bar value, you say Cy bar plus A. Later we will see how to prove it. Huh? These are coding methods. So within that space again you write these things. I'll explain it just right. Huh? Let's see how the calculation becomes too easy. Usually this method of coding used for group frequency distributions. For group frequency distributions. See, usually we say class width. See, we call class width. This is very important one. Now see this calculation. See this calculation. Huh? So this thing you have done under O levels. This coding methods has done. Now see the procedure. See this one clearly. Now you have to select here xi mid value as A. Mid value or value close to mid value. You take as A. Then here yi, xi minus A divided by C. We call C class width. Then you get yi. That is xi minus A divided by C. Then here A, these are xi values. These are xi values. Then xi 25, A again 25, 25 minus 25, class with 10. We get 0, no? 25 minus 25 divided by 10, 0. Then xi 15, A 25. 15 minus 25 divided by 2. 15 minus 25 minus 10 divided by 10. Minus 1, minus 2, 1, 2. Okay. Then here x bar mean C y bar plus A. Now C class with 10. A assume mean 25. Y bar here we call y bar sigma fi yi divided by sigma fi. Then here sigma fi known, You take another column, get F5YI. F5YI, multiply here F5YI, minus 20, minus 20, 0, plus 20, plus 30. Then here this will be sigma F5YI, no? Then 20, 20 cancel, we get 10. දැක්කද කැල්කියුලේෂන් ලේසි නැහැටි. දැන් කලින් මම කැල්කියුලේෂන් එක කරේ අර බෝඩ් එකේ ලියනනේ. දැන් එහෙම මොකුත් නැහැ පට ගාලා මෙතෙන්ට ගියාගේ. Then y bar here sigma f5yi 10 divided by 100. Here within this table calculation very easy. That's how we do using coding method of coding. Then finally here we get 26. Same answer. Same answer. Then this coding method we use for mean calculation and as well as standard deviation or variance calculation. For both we can do same. Okay. Do that example. Do it. Now we have done up to some level, then only few calculations, few parameters we have to analyze now. Then next week we can complete all the other parameters. Then you take that tutorial and do calculations under mean, median and mode only. Don't read the question, just do calculations, find it mean, median, mode. Don't read the question. Okay, that's enough for statistics today.